Yes.
AI has been around for a while in the fact that machine learning, but AI has really taken off in the last 2 or 3 years.
I think it's actually since the 50s.
What?
Yes, you might not think that.
What? I've got to say, we didn't even have, we barely had computers in the 50s.
If you just search for teachable machines with Google, and you will find a very fun website when you can create your own little machine learning AI project. And so I taught the machine how a Coca-Cola can looks like and what a Fanta can looks like. I trained the computer, and then I could show my camera and I could see a bar graph. This is with 99% probability a Coca-Cola can, and this is a Fanta.
That's where my doorbell camera gets it wrong, because it identifies me as an animal from time to time.
Well, yeah, I think
I'm not saying it's wrong.
We're on record there, to be honest.
Yeah.
It's not looking at something going, oh yeah, I'm comparing that to all the images I've got previously. It just inherently understands whether it's a cat or a dog.
Understands.
Yeah. Understands. Yeah, no, okay, let's not get picky about it. It's fine.
So I
it's
thought
not a real human. I know it's not a real human, Christian. It's
an animal. Thanks.
Okay.
Hello, everybody, and welcome to this podcast. Today we're joined by our friend Charles Morrall, who is a Swede living in Gothenburg, but sounds completely English as far as I'm concerned. So I'm a little bit confused. He's been eating Scottish cheddar for breakfast today, so that's
it's very confusing.
Yes, it is very confusing. Bless you. So Charles is with us today because Charles is a specialist in storage for AI and machine learning, and that is our podcast for today. So Charles, could you possibly introduce yourself to everybody and let them know what you do for a living?
Yes, hello. I'm Charles. I work at Proact. I have been here almost 12 years. And I used to be professional services, been there for 20 years, but I'm now a data center architect, encompassing whatever we do at Proact with the entire data center. Obviously, it's a lot of storage, but there's also compute and networking, backups, disaster recovery. So that's what I do. And I help the sales. So I'm pre-sales, and I help the sales organization with the technical stuff.
So why AI? Obviously, this is a relatively recent thing anyway.
Yes.
AI has been around for a while in the fact that machine learning, but AI has really taken off in the last 2 or 3 years. So
AI has been around, I think it's actually since the 50s. We've been...
What?
Yes, you might not think that.
What? I've got to say, we didn't even have, we barely had computers in the 50s, so that's quite impressive.
Maybe I'm exaggerating a little bit, but it's been around for decades, how we can program a computer to make decisions for us. But it turns out that is incredibly difficult unless you have a very specific, well-detailed circumstances. Let me give you an example. Program a computer for me that can tell the difference between an orange and an apple, and describe this in code for me. If color equals orange, it's an orange, but an apple could be reddish orange.
Yeah, exactly. I was just thinking the same thing.
The point is, it's practically impossible to describe in computer code even the simplest of AI and tasks. So what has come up, it's been quite a few years now, to an example. The classic example is I have 1 million pictures of cats and I have 1 million pictures of dogs. I have some idea to initially describe to a computer, look for these characteristics. This feature is probably more a cat. This is probably more a dog. And I feed that to the computer as a starting point, and I show the computer the 1 million pictures of cats and the millions of pictures of dogs. And the computer makes an attempt. This is probably a cat. No, wrong. But since the computer already knows the answer because I've written cat on the picture, the computer makes an attempt. No, it's wrong. It gets in a sort of a feedback loop, and adjusts a few. If I look for the whiskers a little bit different, maybe the ears a bit pointy, and goes feedback. The feedback loops goes on and on, like a circle goes. The cycle goes on and on and on, and it tries to and the computer operator or the AI operator or the machine learning expert twists and twiddles a little bit with a few parameters, and after many iterations, the computer has now learned that with 99.9% probability, this is a cat and this is a dog.
So what we're saying here is actually that this is a little bit of manual related to this. We've got to go through and find a million pictures of cats and write cat on them before we actually train it.
Absolutely. I gave you the classic, textbook example.
Understood.
So this is called supervised learning. I already know the answer. Now I'm teaching the computer. I am learning. The machine is learning. That is machine learning.
Exactly. So I don't know if anyone else saw Silicon Valley, the sitcom TV show on HBO a few years back.
I think it did.
But they had an episode where one of the developers there created a hot dog or not hot dog application, which is pretty much the same thing, right? So it was kind of describing how that works by a million pictures of hot dogs and something that's not
a million pictures of beef burgers. That sort
and
of
if
stuff.
you want to try it, I can really recommend. If you just search for teachable machines with Google, and you will find a very fun website when you can create your own little machine learning AI project on the fly. And I've done that. I'm not going to show it now, but I have. What I did was I recorded. I took a soft drink can, a Coca-Cola, and sort of recorded an image. I took a Fanta orange soft drink, twisted around, some mineral water, twisted around, and I fed the machine with this data, maybe seven different kinds of soft drinks. And so I taught the machine how a Coca-Cola can looks like and what a Fanta can looks like. Then I trained the computer, and then I could then show my camera, and I could see a bar graph. This is with 99% probability a Coca-Cola can, and this is a Fanta can. You can just go ahead and try it. It's a fun little experiment. It takes a few minutes.
That's where my doorbell camera gets it wrong, because it identifies me as an animal from time to time.
I think
I'm not saying it's wrong.
We're on record there, to be honest.
Yeah,
but that's because it doesn't understand what Yeti is. That sort of stuff. If it understood Yeti, then yes, we'd be there. So yeah.
And this comes quite easily to the realization that there's a lot of data. To saw all these cats and pictures of dogs and soda cans, Coca-Cola cans. And when it comes to the practical applications, I do a lot of work. I have a lot of contact with the automotive industry, which is strong in this part of Sweden where I'm at. Volvo Car Corporation is headquartered here in Gothenburg. And obviously Geely owns Volvo Car Corporation, and Geely has started a number of companies surrounding the sort of automotive industry, and particularly a company called Sensiact, who actually is wholly owned by Volvo Cars, and they develop the systems for autonomous driving and assisted driving, the machine, the display and the big red warning sign in your car if you get too close to the person or the vehicle in front of you.
That's where that animal kind of thing might be a disadvantage for me, though, because if the car identifies me as an animal, it has to decide between do I hit the animal or the elderly woman on the pavement? They're going to choose me every time. So someone's got to correct this.
Yeah, it's a bad choice, though, Christian. To be honest, let's face it. If it was an elderly woman on the pavement, we'd hit you anyway, rather than the elderly woman. But
that's fair.
The ethical implications of a completely autonomous driving solution is not something I'm really prepared to go into details.
Exactly.
The point is, what I'm making is all this. These are like petabytes and petabytes of data. The cars go out and they do the little run around, and it's in urban areas, in more rural areas, and they come into the base and they pull out like tens and tens of terabytes, like a flash module thing, and plug it in and upload it, and then it's crunched. So in an aspect which I feel is a little bit overlooked when new developments in AI and machine learning. I'm not talking about the car and automotive industry. They've been doing this for quite a few years. They know this produces a lot of data.
Yeah.
And they build systems we can not only have the compute that actually do all these computations, we actually need a lot of capacity and performance to feed the compute machines. This is hugely important. The automotive industry and those who've been around for a while, they all know this, but I do come into a lot of new ideas in maybe research, and I work with universities, and they've gone on and bought this new fantastic machine with a lot of compute power. The data is what? No. And it's not like they choose not to. They simply don't realize how important it is.
So we're focusing on CPU and sort of networking cards and all this other sort of shiny stuff that we're getting from the chip manufacturers these days, and we're not really thinking about, well, where are we going to store this 150 terabytes worth of data per day, or whatever it turns out to be?
It's simple. That's the question. Where do we store all this data? But maybe more importantly, how do we make the data storage device capable of delivering data to the compute machine? Because the compute machine is the shiny object that they blow the budget on, because that's what they want. That's what they have in the laptop. And now they brought a much bigger version of it, and they install it into the data center, and they install a flash drive in the and no, please don't.
No, but like everything else, it's interconnected, right? But again, it's the same thing. It's the GPUs, it's that kind of thing that gets into the news cycle. That's where the innovation
gets
happens.
The attention.
That's where you
look. Gets the attention. If you bring up like NVIDIA, they are hugely successful. I think they at some point fairly recently were the highest valued company in the world. And
but there's all these surrounding things that also need to kind of support the capabilities that the GPUs have, which are outside of the realm of the GPU itself.
Yes,
which is basically infrastructure, right?
It is infrastructure.
Designing the data center infrastructure for AI workloads.
That is huge.
Isn't all that different from designing data centers for other things, except perhaps the performance issues or performance needs that you have?
The performance issue is definitely something very high up on the agenda. It's quite simple to explain. You bought this fantastic machine with GPUs and compute power. Now you have to feed it. Unless if you don't, the investment goes. Well, the investment isn't worth it. You don't get that leverage from the investment in compute and GPU power if you can't feed it with data.
It's quite bizarre, actually. It's similar to what we had at the birth of VMware and virtualized infrastructure, in the fact that traditionally what would happen is you would have each individual server had its own storage and its own selection of disks, and it would run those disks and quite happily, thank you very much. And then all of a sudden we went to, well, let's just take that physical server and put it inside a hypervisor, and let's run it off a storage array. So now you've got 50 servers hitting a bunch of disks. But you didn't put 50 times the amount of disks like that you had in the previous server. You put like 5 or something on those lines. So rather than previously having maybe 150 drives to service it, this virtualized infrastructure now had 10, 15. And everything just dropped through the floor performance-wise, because those disks just can't service those machines as fast as the dedicated storage could. So we're in the same situation, aren't we? We're saying
it's very, very similar to the same situation, because it's never. But I think it was maybe even worse, because when we went to VMware, we need to have centralized storage with good performance, but how it wasn't maybe not correctly sized at the moment. So storage, we need storage to what are you talking about? Because the data scientists, the developers, the very, very smart people, they're not infrastructure experts. Obviously not. Why would they? They have other things to think about.
Charles, I'm not a data scientist, but I'm an infrastructure guy, so I understand that part of it. I don't understand anything what the data scientists are doing with the large language models or the training or whatever. Right, so it's a different reality.
To get further into that issue, Proact in Sweden became a partner to an organization called AI Sweden, which is it's the business side, they are partners, and the public sector. A lot of public sector organizations, they are partners. A lot of universities are partners, and we all come together and collaborate for applied AI. It's not theoretical research; it's how to actually apply AI to real world problems. We've been members and partners for a few years, together with, for example, NetApp. They are also partners with AI Sweden. What's going on here is that. So I'm there in the lab. They have offices around Sweden, but in particularly in Gothenburg, where I'm based. They have built up a lab, and NetApp has donated equipment, and I donate my time to manage this equipment, which means I like to say I'm immersing myself in this ecosystem. The people, the actual scientists. I sit in a like open office, and I hear what's going on, and I jump into the lab, and I can in a second just collaborate with scientists, and I sort of pick up the language the data scientists and developers are speaking. And when you say this requirement, I know this translates to this infrastructure requirement.
But going back to your example with those, 150 terabytes of data a day or a week, how actually is that problem solved? Because it's adding up. It's really, really adding up.
The problem isn't really solved because it comes back to those who consume AI, machine learning resources, the scientists and developers. As we come back to the compute power. Yeah, we bought in the shiny machine. Oh, and by the way, to store these 150 terabytes of data, and is it valuable data? Well, can you recall the car going around again? No. And the data, if I go back to the example with the cats and dogs, a human being has sitting in front of a computer and with two buttons, cat, dog, cat, dog, cat, dog, cat, dog. And so a human has added value to the raw image data by, it's called annotation. It is now annotated data. So there is a value to the data. And I do know from automotive again, they sometimes buy so-called data sets, images and videos that some humans have actually gone into at this time at index in these coordinates. There's a human face. And these coordinates, something else is going on. So the data set is hugely valuable. And in some cases, maybe you have your own staff adding value to it. So the data is massive and it's hugely valuable because there's so many man hours has gone into curating and annotating this data. So not only is it a lot of data, it has to have a backup copy.
Oh, Struth, you got to back it up as well?
Yes. To ask, it is solved. It is not solved. That is what I'm actively working on. How to or how shall I say, promote or explain that the importance of data is much, much higher, but the it's not at all on top of mind at a data scientist or someone who wants to use machine learning. It's an infrastructure service that is just around.
Yeah, it just exists, right? You buy it from the cloud. You just buy it from the cloud.
Since
it's fine.
The volumes can be so massive. I talk of something about called data gravity. It's not my invention, but like these terabytes are now into the petabyte range. This is a lot of data, and if you need to have a secondary copy and maybe a geographically distributed copy somewhere away from your data center, that gets really difficult. We can solve it. Yeah. It's just to get into the discussion early, so we solve that problem too.
And bandwidth is going to be an issue here, isn't it? Because the immediate thought is, let's just stick it in the cloud. The cloud's got infinite storage. We can throw whatever we like in the cloud. But we've just been talking about the fact that you need to feed the monster.
Yeah, we need to feed the monster.
You can't feed the monster with bandwidth coming from a resource that is 150 miles away.
That is something people have attempted it. And the company I talked about earlier, they are a fairly new company. They've been around maybe less than 10 years. And they initially thought that, no, we are not going to have a data center. We are just going to go do everything in the cloud. That didn't really work out at all because the volume of data is so massive.
Well, it's one of those things whereby it's fine as long as you also put your compute in the cloud.
Yes.
You need to. So everything is in the cloud. Well, two things there. First of all, you're then not in control of what sits between those 2 points. So there may be really bad networking or misconfigured networking in between those 2 points and you can't see it and administer it. But also it means that you're then paying the cloud company for both the compute and the storage. And that makes it very expensive. This becomes
really expensive really fast when you start to experiment. So that's something I see that for practical and financial reasons, we come back from the cloud. It doesn't make sense. At a certain level, it's just cheaper to run everything in around data centers. And
but then you run into another problem as well, and that is the availability of GPUs, right? So it might be easier to actually get access to proper GPUs in a cloud setting because they're already there than it is to actually buy one. So it's 100 of them. So
all cloud hyperscalers are also buying 10,000, 100,000 of GPUs, and that's actually been a point made to me by a scientist or a developer. We cannot get GPU resources in the cloud. They are all booked.
Crazy. But coming back to the storage part, there are some techniques like deduplication and stuff. Is it something that can be used in that area?
It can be used, and it can be used, and it is used.
Does it scale?
As the volumes go up, there's more potential for compression and deduplication. But in many cases, the images, if you're talking about images, they cannot be really compressed because they are
images and video.
They are already compressed.
Yeah.
So talking about the images and maybe even movie film sequences that are analyzed, but on the subject of machine learning and what is hot is probably ChatGPT that came around a year ago or something like that. And now we're talking about text, large language models. Say you can interact with text, and so I thought that won't consume that much data. That was incorrect.
Yes, that was incorrect. It's like we're making this up as we go along, so it's very difficult to predict, isn't it? Really, is that sort of
yes. So what I've seen is, and again, I touch and I work a little bit with. It's called natural language understanding, which is hot to be able to understand human speech and to understand the language we are speaking. So I came across. I was in the lab, and I was looking into the system because I think we had a little bit of a power outage. So is it okay again? Why is this storage device at 99% full? And it turns out the natural language team, they had just filled that with data and data and data and data. And I asked them, is it something wrong? Are you like copying it over and over again? We'd like 4 times more than that, please. So yeah, data is everywhere. It's not only images and moving pictures. It's also text and speech consuming a lot of data.
Do we find that, though? Obviously, there's different types of data, though. You've talked already about there's training data, there's validation data, there's test data, there's probably then resource to hold the models themselves once you've created them. Is the type of storage that you need for those things the same? So do you just take it all off the same array and put it back on the same array, or do you need different storage for different elements? Like you always need solid state disk for training, but you don't for validation and this, that, and the other. Is there different performance requirements?
The performance requirements for training and machine learning that's where the performance requirements really are.
Right. So it's primarily the training data.
Yeah. That I would say that when you actually then use the model that you have trained, that doesn't actually consume that much.
Yeah, it's all built in by that point, isn't it? It doesn't compare. It's not looking at something going, oh yeah, I'm comparing that to all the images I've got previously. It just inherently understands whether it's a cat or a dog in this situation. It's like tiny.
Let's put that in air quotes, right?
Yeah.
Understands, but
understands. Okay. Let's not get picky about it. It's fine.
So I
it's
thought
not a real human. I know it's not a real human, Christian. It's
an animal. Thanks.
I can even mention that now we're talking about the images, and I do also have a lot of work and a lot of contact with the healthcare in the public sector. And you'd think that they would use radiology and X-ray images to now we have to we can find cancer. It isn't a topic, but that's also been around. It is used. But then comes the other aspect. This is highly sensitive data. This is medical. These are medical records. And the jury is a little bit out there. If I take a medical record for a human, a patient, with a name and a date of birth, whatever unique identifiers you may have.
My GDPR alarm's going off.
Yes, absolutely. And if we talk to legal experts, if I just replace the natural name with a John Doe or anonymous, is that now anonymous data? It's still a record. It's still a record of medical data. It might not be. There is no absolute. There is no truth. There is no solid, absolute 100% truth.
It's difficult, isn't it? It's difficult, isn't it? Surely an X-ray of my lung does not represent a decent representation of me. Nobody else knows what my lung looks like on X-ray, so how can they identify me by it?
But ask legal, and there is no consensus. So there's actually even now is a market for, it's called synthetic data. Trained data on real data, and then they actually generate plausible. This is what a cancer could look like. A tumor could look like this, but has never been a human. There's never been an X-ray of an actual human. This is just manufactured synthetic data. It's quite amazing, actually, that even we generate synthetic data to train our machine learning AI to then make decisions for us on real data.
Well, we're doing that a little bit with cars. Again, back to cars. Whereby we're using. NVIDIA have now more or less got to the point, and Unreal have more or less got to the point where Unreal Engine 5 can represent almost real life looking images to the point that a car can look at them and understand exactly what it's supposed to be doing.
There's probably something
going
on there.
Self-training on what essentially is a model of what the world looks like.
So are we
People
going
saying they're doing that with X-ray images and
that is potential application.
Here's my pancreas close up, that sort of stuff.
Yeah, something like that. Yeah, to further develop and train their models without having to worry about is the data sensitive, can it leave the premises? Because the medical records, at least in Sweden, not only are they confined to Sweden, it's even within the county or regional authority borders. They cannot even go to another district or county or region because each region has their own systems and responsible for their own patients. That is a real problem, which of course invalidates any cloud usage in this context. But with synthetic data, that problem is solved.
Absolutely. We've had a lot of stuff about copyright with regards to this sort of stuff. But so is this an issue with regard to when you're buying data sets? You can't guarantee that the information in the data set is copyrighted or not?
Well, I suppose if you actually buy it from the producer, it is valid. But absolutely, on that maybe tangential on that topic about if we can move the movement of data, the sensitive data around. It's something called let's go back to automotive again. We are going to now record all the cars in production. They are not the actual. Those actual cars that are drive around, and we want to record all the images around us. Maybe we can include a few human beings, and it's with GPSs. It's also geographically determined where we are and when we are filming this. Oh, can we take all this data from the North America and Europe and Southeast Asia and China and just plug it together in one huge machine learning factory? No, absolutely not.
No,
of course not.
Are you driving on the right side of the road? Would be a good one, certainly for just the UK
and
Sweden.
There'll be so many laws and national policies that would absolutely prohibit that. So
But another thing. If you go back to the cats and dogs thing and the cars. And people versus humans versus animals and all of that thing. Can you train one model to identify people from hours and hours and footage or from the cars and whatever, and identify human beings, and then use that model to train the car to avoid human beings? I'm not talking about the ethical part of it, but can you use one model that has been trained to identify something and use that trained model to train another model to also understand the same thing?
I would venture a guess and say yes, but I wouldn't be. I'm not that. I'm an expert in machine learning and how it's actually applied. So, I suppose
I'm just thinking if you have something that is trained to identify something, and already knows how to identify something, hot dog or not hot dog. If you can, in theory, use that model as a baseline for something else that has other uses, but then augments it with the trained data from another model.
That is very likely something that is going on in the community.
Yeah.
So what we're going to envision seeing then is basically models that are trained to do specific things that you can use as modules for your own data.
Yeah.
Yeah.
That's something that's going on. I think that might touch on that a little bit, and I'm going to try to see if I can understand it myself and then explain it. These as I talked about, the language models, the large language models that are going around, they are so huge and massive. You cannot practically train them yourself. You would have to buy Facebook's data centers to do it. So. What's going on in a very broad sense? You take the trained model; it's already trained. You just license it, or maybe it's open source, and then you attach a bit of your own data, and so you use the trained model, and they can peek into your own data, your own unique data. And you don't have to train everything again, and you can just use something called a RAG, these days. Retrieval augmented generation. So it goes in and sort of combines the pre-trained model. I might be a little bit wrong here, but it's something like that. You can like look at general model for the maybe Swedish language, and then attach a common medical knowledge. If you type in the chat, I have a sore throat and my fever is 39, and the text in the general language model attaches the medical knowledge base that is available, and then tries to get you a good answer. Something like that.
Yeah, so basically you augment an existingly trained
so this retrieval augmented generation
data.
The RAG.
Yeah.
Nice. So, I mean, and so therefore, again,
that also requires less compute power on your end, because the
that is true. That's true.
Yeah.
And that's exactly where I was going, is the fact that if we're talking about storage, and the businesses must be looking at this and going like, well, we would like to train an AI. We've got a certain amount of data that we need to train that AI on, but maybe we don't want to go out and spend a massive amount of money on resources, or maybe we need to spend some money on resources, but only a finite amount of money. So what they could do is they could cherry pick the components of the LLM models that have already exist that they feel will fit their requirements, and then just train on the components they need. And they may need to buy hardware for that, but they can bolt it together as a sort of like custom AI just for them.
I think
because there are downloadable models that you can use, both from Meta and from others, open source things as well, that are also already trained models that you can use and augment with your own data.
Yeah.
That's available.
I think
you couldn't just throw that onto your local storage array, plug it into your VMware environment and say train. You'd need some degree of hardware necessary to be able to do that, I assume, Charles.
Something like that, yeah.
So, but in reality, if they buy additional hardware, they will need to buy additional hardware necessary to be able to train at any reasonable pace. Is that fair? You can't do this without specific hardware.
You need some hardware setup, absolutely, and that's what I'm working on. A lot of many universities and other organizations, they are sort of dipping their toes into getting some machine learning going, AI models. A lot of developers, they want resources, and I talk to a lot of IT departments, the traditional customers. And as I mentioned earlier, I sort of immerse myself at AS Sweden and pick up the language that data scientists use. And I use that in going to the meetings with the data scientists and the IT department. They do not understand each other. So I sit there like a mediator. You want this, IT department, you need to give this. And I can literally talk. We had a call a while ago, and I talked to both. Can we just set up a 15-minute meeting? Yeah, all right. You need this. Okay, we need to get that. And it was resolved. Like, it's just a matter of understanding both parties. And the IT department, that wasn't so complicated. And the data scientists, they got exactly what they want. And the IT department gets an enterprise grade set up with proper equipment.
Nice.
But surely that could be solved with AI doing that translation part. Natural language things.
I don't know.
No, impossible.
Charles is like a Babel fish. That's the way.
You need me in the middle.
Speaking of translation, how does it translate to changes in the hardware, in the infrastructure? So is there anything that, in your perspective, is being developed by the vendors for storage hardware, storage infrastructure to address that specific need for more, faster, and
there are definitely a number of vendors and companies emerging, and they have been around for a few years to build storage systems specifically addressing AI and machine learning needs. That they are around, and I am studying them. I'm talking to them actively.
Yep.
And but I do also realize they primarily looking to solve the performance issue that we started with, to feed the compute machine, to feed the beast. And when I go back to our more traditional vendors that we've been working with product for many years, I wouldn't say they're catching up, but they are also sort of adjusting their offer and their packaging and their models to also address the issue. But when we come down to the details, we got performance, and we want security, and we want backups, and we want disaster recovery, and we want to have granular, fine-grained access control, and we must have auditing, and it has to be secure, it has to be encrypted, all those bits again. And now the startups, they sort of get a little bit uneasy because they have mainly addressed the performance issue, but all those bits that we have covered over 30 years, they also appear as the requirements come along.
There are things happening in the software kind of space in the data centers there as well. I, of course, know much, or not much, but I know mostly about the VMware kind of thing, way of doing this. And what they've done now is include a kind of prescriptive private AI kind of infrastructure setup inside of the VMware Cloud Foundation suite. So they now have kind of a repeatable building block for building private AI managed through VMware and the VCF stack, which is basically a way of designing how you can do that in your existing virtualized environment. So there's also movement in that, and how to design and manage these things in a way that people know how to do,
which is great. In a virtualized environment. That said, server virtualization is not big in AI and machine learning infrastructure as I see it today. It is, I would say, non-existent, because you don't really need to run virtual machines. The de facto standard is to run containers in Kubernetes environment, and
that's what VMware does in those private AI deployments as well. But the management is through the interface that VMware admins already know, through vCenter, and through how you deploy these things, even though you're not running
I'm sure
Windows VMs.
There's a lot of things happening in that space. At the moment, I'm not seeing much of it in the data center today. It's a Kubernetes environment running on bare metal with probably Ubuntu, Linux, and then they run it on a traditional compute storage, like a compute network storage, like a classic 3-tier setup.
Okay, great. Thank you very much, Charles. Much appreciated. I appreciate you coming in today and sort of chatting to us about this.
Absolutely.
I think what I've got out of it is it's quite a complicated subject, but it appears to be split between two levels, whereby you have the AI teams and the storage teams don't necessarily communicate the same. Is that right?
That is very, very much so. They just need to sit in the room together. Maybe me or people like me can sort of mediate between those two teams, and it's quite easy. You just need to connect and to understand each other.
And I suppose the other thing as well, though, is how important storage is to AI, because essentially, if you can't train it at the speed necessary,
if you can't feed the machine, the machine is not running.
Yeah,
that's about it.
It just sits there. Yeah, being a very expensive paperweight.
Yeah, more or less.
Great. Oh, well, thanks very much for your time. It's been much appreciated. And thank you, Christian and Christian. I won't ask you for questions just because we have no idea what we're talking about in this area, but it's still been a really interesting discussion. So thanks very much.